All right, so we have two vectors in component form, and we are asked to find 4 times the one minus 6 times the other. The nice thing about vectors in component form is the math is exactly what it looks like. But what this means is if I were to draw 4f's, and the way you would draw 4f's is like, you would go right 12 up 2, and then do another one, and then do another one, and then do another one, right? And then go in the opposite direction to draw 6 V's. So it would be like left 2, down 4, left 2, down 4, left 2, down 4. I'm not even going to try to draw it out. But it would look something like this. So even though I said I wouldn't do it, I'm doing it anyway. You're going to end up here. So what's the distance from the very beginning to where I ended? That's what I'm doing with these guys. And like I said, the math is exactly the way it looks. You do 4 times the vector, 12, 2, and then you're going to subtract out 6 times the vector 2, 4. Okay, so kind of like distributive property, you end up with 48, 8, which makes sense. If I'm going to go right 12 up 2, right 12 up 2, right 12 up 2, I'm going to end up going right 48 up 8. And I don't know why I made you a parentheses, but I did. And then we're going to add on top of that, I'm going to multiply negative 6 to both of these. So negative 12, negative 24. So the picture that I drew is way off. That's all right. That's okay. It's the heart that's there. You become 36. If I add what appears to be the x values or the left-right values of the vertex, and then you add these guys, which ends up being negative 16, that's going to be my guy. So again, the picture that I drew was way off. I probably shouldn't have made these look like that. I should have made these look more like that. Something like that. That probably would be a lot more accurate. But again, it's the thought that counts in math. That's always the case. Like and subscribe.